I'm Greg. I work for Verbo, formerly known as HomeAway, part of the Expedia Group. And today I'm going to go through an introduction to Fastparse. Fastparse is a Scala library for creating parsers, and recently we used it at work, and that was a pleasant experience, and it was useful in solving the problem we had, so I thought I'd talk about it. So what is a parser? A parser takes text and turns it into structured data. And you may be doing stuff like this now, and there's a variety of ways of doing it. It's like you may be using regex. Regex is nice for validating strings and doing like string manipulation. It's not great at actually turning that into like structured data. So when I talk about structured data in Scala, we're talking about like case classes and stuff like this. Doing that with regex, not too nice. And also with regex, it gets pretty horrible pretty quickly. So if you're dealing with like nested structures inside your string, that's a bit painful to work with, things like this. If you've like ever written a parser, like I did this back in uni, and I had to use lex and yak, and that wasn't that nice for me. Like it was all in C, and I had to like learn these weird DSLs, and then it generated a bunch of code, and then that was my parser, and it was all a bit complicated, I guess. So that brings us on to Fastparse. So Fastparse is a library written by Li Haoyi, and it allows us to create recursive descent parsers. So with recursive descent parsers, you build like small little parsers for very simple things like true or false. So that'd be a parser for Boolean, and then you can build up like an expression is either a Boolean or a number literal or something else, and then an assignment might have like an identifier and an expression, and in this way you can like build up a big powerful language out of these very simple small parts. And look at how we do that in Fastparse in a bit. It's also like a parser combinator library. So you're building these recursive descent parsers, and it gives you like these are small things that you can compose up, and so you have like these combinators, these methods that allow you to like nicely build up these parsers. And we'll talk a bit more about other features and advantages as we go through. But first, I wanted to like talk about motivation. So like, I work in the growth tech team at Verbo, and I'm very much an application developer. I'm not like writing my own programming language or even really building libraries. So, like, why would I be creating a parser? Why would you guys want to create a parser, right? And I'm not trying to create my language or parse JSON or SQL. Instead, we had a use case come up where we thought a DSL would actually be really useful for our users. So I'll just give a bit of background about domain-specific languages. So we wrote our own very simple language for our users, and Fastparse was useful for that. So DSLs, there's two types of DSLs. There's internal DSLs, and as a Scala developer, you'd have already used lots of internal DSLs. So like Scala tests, you kind of get a DSL for matches and how do I do assertions and check things in my tests. You also get like a DSL for defining your tests. So it's just Scala functions, but it's like it's a domain-specific language. Similarly with SBT, like you have this weird colon equals thing, and that's like assignment in SBT's DSL. And like new things like free monads and tagless final, you're basically defining a very like clean, human-readable kind of DSL that is easy to author, and then you have like an interpreter that actually figures out how to run it. So, and with like free monads, you don't really need to have a parser. You just kind of writing out the AST almost. So you're using lots of internal DSLs already, but there's also external DSLs, which is a bit more interesting to us, and you're already using some of these as well, hopefully. It's like regex is a domain-specific language for doing like matching strings, and SQL is another small external DSL that lets you read from database, and CSS as well. And like all of these are like, with the external DSLs, they're generally a lot less, like they cover a lot less scope. So these are generally like declarative, these are all kind of declarative languages. There's no like control flow generally, unless you're using file for regex. So they don't try and do too much, but hopefully easier to author. So yeah, when you look at like internal versus external DSLs, they're embedded in the language. If you're using Scala tests or SVT, you're kind of expected to know Scala. Like if you look at someone else's build SVT and you don't know Scala, there might be some weird stuff there. External DSLs, like there are plenty of like business analysts that know SQL. Like it's not like they can be a lot easier to author than learning like an internal DSL and the whole language around it. So yeah, we're going to look at like an example. We're going to look at an example DSL which we wrote at my company, like something similar, and how that looks in Fastparse. So first, I need to like explain the problem. So we have this fancy architecture diagram. We have a link generator, and our users give it a list of destinations and a table of link templates, and then we like run each destination through all the templates, and we get like a massive list of links at the end. Not the most interesting problem, but like this is a business problem we had to come up. And destination list, not very interesting, it's just like a number of destination IDs. And our link templates, this is what they used to look like. Something like this. So we had, like a link has like a text and URL. And the text, you can see we've got these placeholders. So like given a destination ID, we can populate these variables and do some substitution. And then the URL is like a fragment of a URL, and we're going to use this to like string concatenation and build up our URL. And like, yeah, this is what we had, and it wasn't that nice. This is what we have now. So the text is exactly the same, but the URL piece is quite different. So now instead of giving like a URL fragment, they specify in this little DSL we provided, like it can be, we're linking to the landing page for that destination, or we're linking to the search page. And if it's a search page, we can provide some like filters that are applied when you go there. There's a number of advantages to this. So one thing is like doing string concatenation with the URLs. It's always like, did I have the slash? Do I need another slash? And like, what if the users like did a typo and they did like search/keyword colon? And like, it's not very safe. So it's very easy for our users to just mistype things. And with this, like, it's kind of easier to author, hopefully. It's in their domain, it makes sense to them. And also, like, we use Fastparse to build a parser for this. And when the users upload this table, we can actually go through and like, compile these URLs. And yeah, so that's a lot nicer. You won't just generate bad links and then find out later. You'll actually know up front. And yeah. So does the domain make sense to people? Cool. Let's look at how we implement this and how Fastparse looks. So this is the simpler one, the link text template. So it's just text with placeholders in, but before we were using like find and replace, and like find and replace curly braces destination. But then what happens if they had like a typo and they typed destination wrong? Then it would just like silently not replace it, and your links look really weird. And then we had to we do the replacements, then we check if there's a curly brace, and it was all just pretty ugly. So we ended up using Fastparse to parse the template with these just simple placeholders in. And so this is what a template will look like at the end. It will have a sequence of tokens. So this is either a literal or a variable. And given these literals and variables, we can give it a map of all the variables we have available and render this template. And yeah, when we receive this table, we can compile all the templates up front and then just reuse them with our different values for those variables for each destination. So yeah, this is actually quite fast. This is not very functional, horribly mutable code that should be quite fast. yeah, it's also like not particularly safe because you could like, what if the key isn't in the map and stuff. So in reality, we'd probably have an either in here or something. Yeah, this is hopefully quite simple. And then, but the bit where we want Fastparse to help is how do we get like our string and turn it into these tokens. So this is the parser. I mentioned with recursive distant parsers, you build up like small, simple parsers, and then you compose them up. So like at the top, you kind of start with the small pieces, and at the bottom you have like what we've composed. So here we can see like at the end we have anything that has a start, then like a literal or a variable, and we just repeat that over and over, and then it ends, and then a literal is anything that doesn't have these curly braces in, and a variable is a curly brace followed by an identifier followed by another curly brace. And yeah, already like, so there's not much lines of code, and hopefully it's fairly readable, but it definitely does look a bit weird. There's like a weird DSL here. So P here means parser, so we're creating like a parser, and that parser is going to read like a curly brace, and this symbol means and so like it's curly brace and identifier, and hopefully that's fairly readable. Other thing of interest here is that this, so we have repeat, so this is going to take A to Z and underscores many times, and then we just say like this weird exclamation mark means capture, so this is like capture the value there. So if we remove this, then we'll see the return type changes to like a parser of unit. So that's how you like the relevant pieces of the string, you can capture them. And then you can, once you have that, we can then map over this, and we have access to that string, and then we can like turn it into some structured data. And in that way, like we just build up this thing that gives us a template. So it's just 4 lines of code to build the parser, and then we just, here I'm just like calling Fastparse, do the parsing. We'll just have a quick look at the usage of that. So here, I'm just, I've got 3 templates. 2 of them are valid, 1 of them's invalid. And yeah, we parse those. You can see like we can turn that into a literal and variable. And when it fails, we get like an error message. And the error message like tells us where the error is. So it's at like character 10 on the first line. And yeah, we found invalid, and we expected curly brace, like the variable. Yeah. It's not actually the best error message, to be honest, but that one's okay. The other ones that we'll see in a minute are a bit nicer. Yeah, and then like you can actually render that, and that looks as you'd expect. Yeah. And like this is pretty simple, and we could have just, this looks quite a lot like mustache templates or something. We could have used that, but this is already quite nice because it allows us to do a few things. So we were able to like, we can go through this template which has these tokens, and we can like look at all the variables that are being used. So we could check before we render, do we have all those variables available for this destination? If we don't, we tell the user like these are missing, and these are what were available. Maybe you meant one of these. So that's been quite good. Also, by doing it ourselves, we could do things like, if we wanted to, this map, we could make it like, if this was actually calling like a web service or a database first, then we could have it like defer evaluation and stuff like this. So there's some cool things we're able to do by just doing this ourselves, and the parser was like literally 4 lines of code. But the more interesting example to me is the URLs. So this is like the structured data we're going to get at the end, just some still traits and case classes. So a URL is either going to be a landing page or a search page, and if it's a search page, it has filters, and filters are either like this vacation rental allows property pets, or like we want to make sure it sleeps at least n people, and we have like types here as well, right? So if it's a pet, that filter has to be a Boolean. but if it's like number of people, then it's a number. And yeah, this is our parser. It's a bit more, but still not crazy. And yeah, you can see, so you either have a landing page or a search page. Landing page is super simple, just match landing page and then throw, we don't capture anything, we just return landing page. And then search page is this, followed by some filters. And then filters returns a sequence of filter, so that then allows us to create our search page. And filters is just a filter repeated any number of times. And this is just pet included or sleeps minimum. And then here we just have the string, and then we're actually like, we have this type safety, right? So we're checking that it's a Boolean, and even like it's a positive number, just it's a number. Yeah, so this was like quite simple actually for us to do, and the error messages with this are quite nice as well. So here I've got like 4 valid URL templates, 4 valid URLs and 4 invalid. So the first 4 come out as you would expect, but then like this one, like it tells us like found other page, but it has to be either landing page or search page. So the user actually gets like some meaningful feedback about it. And likewise, when they didn't specify a valid Boolean, they get like useful feedback saying like these are the available options. And we didn't like write any code specifically for the error handling. So like this is really cool actually. I think that our users can pretty much read these errors, and it's just out of the box. And the why is quite interesting, so I'll just quickly cover that a bit. So yeah, Fastparse is recursive, allows you to create recursive parsers using parser combinators. This isn't a new idea in Scala, so parser combinator library was in the standard library like, I don't know, 5+ years ago. And this is just like a better version of it. So this is like a few hundred times faster than the one that was in the standard library. And part of the reason why is I said this was like and, but like this is and. And when I put this in, we're saying like, this is called a cut. And this means if we got here, like we can't go backwards. Because with recursive design parser, what we try and do is we try and parse this. If it fails, we move to this. But if we get like here, if that fails, there's no way that it's going to be anything else. So we just want to fail fast. So that actually helps, like in the invalid cases, that makes it fail quicker, and it was also what allows you to get like nice error messages as well. The syntax, like another one is this. This is like, what is this? But actually, there's a really good reason for it. Well, so in Fastparse is on version 2 now. Fastparse version 1 didn't have this. And in version 2, he added it, and it gave like a 2 to 4 times speed up. So I just think that's kind of worth it. It's not that bad. Yeah. Okay. So yeah, in summary, Fastparse lets you create parsers. I think it's quite nice to use. The DSL, if you kind of ignore some bits, it's quite readable actually. And if you look at the docs are really good. If you look at what those methods do, it makes sense. It's really fast, so you can actually, like Li Haoyi wrote like a JSON parser in like 37 lines of code, and it performs better than like PlayJSON and some other JSON libraries. So like CSC is faster, admittedly, but you could do really well with just this. It's a lot simpler as parser, and you even get nice error messages. So. And the other thing is like, this isn't just for people like writing languages. I think this is actually useful for application developers. If you're doing crazy stuff with regex, or you have like tools where you're creating tools like power users, and you might need a DSL, I would recommend Fastpast. So thanks for listening. Any questions?